conservation of charge. We are very familiar with this fact that when bodies are rubbed together, charge is transferred from one body to another body. In this process, no new charge is created or destroyed. It only gets transferred from one body to the other. Here we can see that before rubbing, the total charge of this system is 0. After rubbing, electrons from glass rod are transferred to the silk cloth. Here, no new charge is created. Therefore, in spite of rubbing, the total charge of this system is 0. If we find appearance or loss of charge in any body, it means that only transfer of charge has existed. We cannot create or destroy the charge. Here we can see that initially total charge of the sphere is 0. When a charged glass rod is brought near to an uncharged sphere, it gets charged by appearance of negative charge at one side and positive charge at another side. But initially, the total charge of the sphere was 0, and after appearance of positive and negative charge, the net charge is still 0. Total positive charge at the right side is equal to the total negative charge at the left side, so now net charge is 0. If we change the positively charged rod with negatively charged rod, in that case, again the total charge of sphere is 0. Here, sphere is already charged, but when we touch it, its charge disappears. It does not signify that we have destroyed the charge. When we touch it, all charges of the sphere gets neutralized by the transfer of electrons from the ground through our body. If we take the sphere, our body and the earth ground in combination as a system, then in this system the total charge remains constant. Independently, conservation of mass is not valid for high energy particle physics, where mass converts into energy. But conservation of charge is still valid here. Let us understand it by an example. Conversion of a neutron into a proton takes place in high energy particle physics. Here, when a neutron converts into proton, it emits a beta particle and antineutrino. Initially, neutron was single system and its net charge was 0. After it is broken, proton acquires 1 unit positive charge, whereas beta particle acquires 1 unit negative charge, and antineutrino has no charge. In combination of all three as a system, net charge is again 0. Therefore, what we have learnt here is the total charge of the isolated system is always conserved.